I would recommend friction alone is not gonna stick the table. We're gonna close the door. Somebody's not gonna close the door. We're back. You look like you got Who's this dry? Okay, don't use it on the flash. Oh, this is so fun. Oh my god. They're not the best dry erase boards, but they are dry erase. Indeed, they are. All right. So what we're gonna do is lock it in. There we go. We're gonna fill in these other two columns. So we've given you the inequality symbol. We're gonna write it in interval notation and we're gonna give it a sketch. If you need to, start with the sketch. Yes, dear. This is 2.6, yes. This is 2.6. 2.6 is inequalities, and then so is 2.7. So we're going to be inequalities to the end of the chapter. The quiz tomorrow? No. 2.4 and 2.5. It's always literally on the this thingy. If I gave you on like the first day, and I do try and put it up on the board on the left hand side over there. DC's at the bottom. Does say quiz for Friday. Tomorrow's Friday. I know, shooketh. And long weekend.
Yes, and my birthday.
Ooh, happy almost birthday then. Ooh, that is very special. So you'll be having a big party. We'll have a birthday. To be fair, my birthday was back to school night and I was here for more than 12 hours. Just saying. Yes, I was here for almost 13 hours on my birthday day. Super fun. Just saying. All right. So when we have something like this where A is less than X is less than B, what we're saying is that my solutions to whatever my inequality are between A and B. But it cannot be A and it cannot be B, right? Since it doesn't have an equal sign, that's when we use our open circles. This is like an Algebra 1 thing, so it may be like way back on the shelves and we have to dust it off and bring it back forward, right? Putting it in interval notation, the smallest our answer can be is A. The biggest our answer can be is B. Since it's not included, we use parentheses on both of them. This is the parentheses versus bracket situation, okay? Right, like it's way back on the deep shelves. We're pulling it forward, blowing the dust off, getting it reorganized before we try and use it. All right? Yes? I heard a wait.
Can you say that one more time? Because I would I heard you, but I wouldn't.
So parentheses is when we aren't going to do that.
Yeah, like what is that?
That was real judgy. Judgment-free zone. We're like Planet Fitness in here. Judgment-free zone. Yeah, we need the lunk alarm. I'm just going to put it in front of your desk and just hit it every now and then. Woo, woo, woo. Okay? So parentheses is when it's not equal to. I can't touch it. I think of parentheses as an obnoxious little sibling. Parentheses are like, I'm not touching you, I'm not touching you, I'm not touching you. I can get really close to it. It's obnoxious. If we can touch it, oh snap, like on the next one, we use the square. So this one, the smallest it's going to be is A, and the biggest it's going to be is B, and I can touch it. If it is a valid solution, we use a square bracket. If I could plug in whatever that value is and get something that works, we use the square. So on our sketch, it's going to be a real similar vibe, but this time we use closed circles because we're equals to. And it's still the values in between. But with those closed circles. So closed circles are square brackets, if you're familiar with our circles. Open circles are parentheses. Square brackets, I can touch it. Parentheses are annoying little siblings. As a youngest sibling, I feel like I can make that claim. Because I was 100% that little sibling. Okay. So, then we're going to do our next one. X is less than or equal to A. So again, I'm going to start with my sketch on this one because it helps us see sometimes. Are we going to have an open circle or a closed circle at A? Closed circle. And if X is less than, are we shading to the left or to the right? To the left. To the left, to the left. Okay, I was going Beyonce, not Cha-Cha Slide. Everything you own in a box to the left. All right, so what is the smallest this can be?
Negative infinity.
Negative infinity. Can I touch negative infinity? No. Infinity will always use parentheses. Whether there's negative infinity or positive infinity, it uses parentheses because I can't point to it and go, there it is, I found it, because it's an idea. Our biggest number here is A, and since we have this equals to, since we used a closed circle, we use a square bracket. We can mix and match. And I know my A's sometimes look like 9s. It's okay. We're all A's here. There's no numbers on this page. Same thing with our less than A. I'm going to hit the button again. Judgment free, y'all. Judgment free. Judgment. Okay. Be nice to each other, y'all. Come on. All right, so now we have that X is less than A. So it's a really similar vibe. Still coloring to the left, but this time it's an open circle. So our interval notation is that the smallest is negative infinity and my biggest is A, but it cannot exactly equal A. It just can get real close, but it cannot equal A. Any sense we're going to be doing a whole lot with inequalities by the sheer number of choices we have. Same vibe on the B's, except this time they're facing the other direction. Got my X is greater than or equal to B, which means at B, we're going to have a closed circle. And this time, it's bigger, so we're coloring to the right. So when we're putting this in interval notation, what is the smallest my solution can be? B. What is the biggest my solution can be? Infinity. Infinity is an idea, not a number, so it can never equal infinity. But here it can equal B, so we use a bracket. Infinity is an idea. I cannot touch it, so we do not use the bracket on it. We only use parentheses. Also, Buzz Lightyear is wrong. You can't go past it. You cannot go beyond infinity. Buzz Lightyear's wrong. He is. Okay, 3 more of these and then we'll get out of this table. This next one is a very similar vibe to the one above it and the one above that, where it's almost identical, except this time it's not equals to. So it means we have an open circle at B. B is still our smallest possible value. Infinity is still our biggest possible value, but this time I can't touch either one of them. I can get really close to B, but I cannot equal B. Our second to last one has a very similar vibe to the top 2, except this time we're mixing and matching, and that's okay. Ooh, okay, I'll put all my letters underneath. So we've got that A is less than X, which is less than or equal to B. So it's between A and B, but one of them has a less than, one of them has a less than or equal to, and that's totally fine. One circle's open, one circle's closed. So my A is the smallest it can be. That looks like a 9. Even I can see that one. There we go. B is the biggest it can be. A gets a parentheses. B gets a bracket. Our bottom one is that x is between negative infinity and positive infinity. It's kind of everything, right? It goes from negative infinity to positive infinity. Also known as all real numbers. Capital R with 2 vertical sticks is the lazy way to write it. Capital R. Stick.
Oh, like a dollar sign.
Like a dollar sign.
I don't know why that.
I was going to say, we overthink that every time. It looks super duper fancy, but it is literally just a capital R with an extra stick. Okay? All real numbers. If it's all real numbers, that means no imaginary numbers. We love that. Capital R, extra stick. That's what we just did. All right? Or you can write all real numbers. But I know we don't like to write words. As few words as possible, which is why I give you the R with the extra stick. Because that's easy. Easy peasy. Okay? Questions on this table. We're going to be using inequalities a bunch over the next 5 days. Through the notes at the end of this chapter. I'm being generous. I think it might just be 4. But they gonna come up. Because what we're going to do is we're going to be solving inequalities. It's going to smush together with all the stuff we've been doing. Finding our solution. Which means our solution's going to be in that interval notation. Our solutions are going to look like these.
When are you going to take our first test?
Chapter test, Unit 1 test is not this Friday, but next Friday.
Is it only over Unit 1?
Unit 1 is chapters 1 and 2.
Okay.
Yeah. Unit 1 is chapters 1 and 2.
Next Friday?
Next Friday.
Okay.
As soon as I get it. As soon as I get it, I will make copies and give it to you guys. That's going to be kind of my quest today, is to go figure out when I'm going to get that. All right. So let's look at this one. Starting out as simple as we can. Subtract 8 on both sides. And we get that 3x is less than negative 1. Get x by itself. Divide by 3. And we get that x is less than negative 1/3. We need to write this in our interval notation. If it helps, draw your picture. So we have negative 1/3. Are we doing an open circle or a closed circle? Open, because it's not equal to. And if x is less, it goes this way, right? So for our interval notation, the smallest it's going to be is negative infinity. The biggest it's going to be is negative 1/3, and I cannot equal 1/3, so we use a parenthesis. Okay? So we're taking our answers and putting them into that table, basically. You don't have to draw the line picture, but if it helps you do the interval notation, do it. There will be times when drawing the line is going to be really helpful, and I'll show you when that happens. Okay. Now the second one, it's all fractiony and scary. We hate fractions, right? Only when they give us hugs? Is that what you said?
Yeah, that's what I like.
Okay. I'm going to go with moving on. I'm not entirely sure what that means. All right. What's our instinct on this one? You can add 7 to both sides. That's fine. One-fifth x plus 11 is greater than or equal to 1/3 x. That's fine. Then what can we do? Because it's kind of gross. Multiply both sides by 5. That would be my suggestion. That's going to help us get rid of the 1/5. So we're going to have x plus 55 is greater than or equal to 5/3 x. Then what? Multiply everybody by 3. Let's get rid of those denominators. So now we have 3x plus 55 times 3, 165. Greater than or equal to 5x. You can also do the multiplying up at the top. That's totally fine. Gives you smaller numbers, but I'm just following y'all's lead. Now what? Subtract what? 3x. Just couldn't hear you. Because I'm old. 165 is greater than or equal to 2x. Divide by 2. 165 over 2 is greater than or equal to x. We need to put it in our interval notation. I'm going to rewrite that because that looks really terrible. 165 over 2. There we go. Does it matter what that is when we're looking at our interval notation? Nope. We don't have to divide that out to get it to a decimal. I don't care. All I know is that wherever this guy is, it can equal that, and my x's have to be smaller. So our smallest is going to be negative infinity, and our biggest is 165 over 2 with a bracket because it can equal. Just zooming it out so we can see the whole thing. Okay, questions on those two? We're going to do some betweeny ones. The between ones are very similar. We just have to be careful because we have to do it on all sides, not just both sides. On the infinity, no, there's never a bracket on the infinity. Bracket on the 165 over 2 because it isn't equals to. Or 165 over 2. I don't know if I said all the words. Okay. So we have 3 is greater than 4x minus 2 is greater than negative 5. We're aiming to get x by itself in the middle. Add 2. So I'm going to add 2 here. I need to add 2 here and over here. Add 2. So we're going to have 5 greater than 4x greater than negative 3. We're not going to add 3 on both sides. We're going to leave everybody on the other sides of the inequalities alone. I want x by himself. Divide by 4. All I need is x by himself. So we're going to have 5/4 is greater than x is greater than -3/4. What's up? We see it? Okay. So if we were to put this on the number line, what's our smaller value? The -3/4. And our bigger one is the 5/4. We have open circles on each one, and we're coloring between. X is between 5/4 and -3/4. When we are in interval notation, it has to go smallest to biggest. It has to. So we're going to have our -3/4 on the left with a parentheses. And our biggest is 5/4, again with a parentheses. So it has to go smallest to biggest. If you put 5/4 comma -3/4, it's not right. It has to be smallest to biggest in interval notation. Okay? Bringing it up to our next one. What are we going to do on this one? Multiply by 5 first. If I times this guy by 5 and this guy by 5 and this guy by 5. That's going to cancel out that denominator there. So we have 15 is less than or equal to 2x minus 9 is less than 35. Then what can we do? Add 9. Boom. Here, here, and here. So whenever we have a between, we're going to have to do it 3 times. So we have 24 less than or equal to 2x less than 44? Yeah. I'm good at mathing. Then what? Boom shakalaka. Divide by 2. 24 divided by 2 gives us 12. Less than or equal to x less than 22. What's up? I heard a what? We okay? Okay. Cool, cool, cool. Just checking. So we have our 12 and our 22. Open circle or closed circle on 12? Closed. Open circle or closed circle on 22?
Open.
Boom shakalaka, color in between. I don't know why I'm saying boom shakalaka so much today, but I am. Is happening. So our interval notation is 12 with a bracket, 22 with a parenthesis. Okay? All right. Next ones. Let's do this one first, and then we'll do the other one that looks a little scarier. So we have 0 is less than 4 minus 1/3 x less than 2. Go slow, be careful. What do we need to do here? Subtract 4. Okay, you can get rid of the inequality or the fraction first if you want to. It's totally fine. Minus 4 is less than -1/3 x is less than -2. Then what? Times by 3. Totally fine. Gives us -12 is less than negative 1x is less than negative 6. Did I hear I'm lost? Is that what I heard?
I just was not paying attention.
Okay.
But I got it.
Okay, cool. Just checking. Then what? Divide by negative 1. And we switch our signs. When you multiply or divide by a negative number, every single sign flips. So we're going to have positive 12 is greater than x is greater than positive 6. When you times by a negative or divide, you flip your sign every single time. Okay? So we wind up with 6 and 12, and our x is still between them. That 6 looks weird. There we go. Less weird. So our interval notation is 6, 12, and both in parentheses. We are going to be using interval notation for pretty much all of our answers from here through the end of the chapter. So we're going to be using interval notation bunches and bunches and bunches and bunches, okay? So get used to it. Now we're going to do one like this, and they look a little scary. So I have products on my inequality. So what we need to do, multiply them out. Distribute. So we're going to have our 8x squared plus 10x minus 12x minus 15. That's doing this distribution. I heard a what. And we're going to do this side. Same process. 8x squared minus 56x plus x minus 7. Yes, dear.
When you remove the...
Oh. You don't. Just copy it down correctly. Our inequality signs should not change whether they have the equals to or a less than. That's just called I'm bad at observation. So I'm going to simplify these. We're going to have our 8x squared minus 2x minus 15 is less than or equal to 8x squared minus 55x minus 7. Get our x squareds together. What do? Subtract 8x squared minus 8x squared. Oh, look. They disappeared. We love that. So we're left with minus 2x minus 15 is less than or equal to minus 55x minus 7. Add the 55x. If we add the smaller one, we will wind up with significantly less negative coefficients, which means we may or may not have to change signs. So I'm going to take the smaller x, and I tend to move that one. So I'm going to add 55x. It's not wrong to go the other direction. Again, freedom of choice. You can do whatever the heck you want. As long as you get to the same solution, we're fine. So we're going to have 53x minus 15 less than or equal to negative 7. Add our 15 on both sides, and we get 53x is less than or equal to 8. And we're almost there. What is x less than or equal to? 8 over 53. So our interval form, what's the smallest? Negative infinity. And our biggest? 8 over 53. Infinity is an idea, so we always use a parenthesis. Are we using a parenthesis or a bracket on 8 over 53? Bracket. That one's longer because we had to multiply it out. But other than that, it's a real similar vibe. I was going to say we have 2 more, but they're not this long. Okay? They look a little scarier though. Because we have x's in the denominator and we get a little scared. These are the last 2 for the day. Okay? If something has to be less than 0, what kind of number is it going to be? Negative. In order to make a fraction negative, if the numerator is positive, what does the denominator have to be? Negative. So my denominator has to be negative. So we're going to yank that sucker out. My 3x minus 5 has to be negative. So it has to be less than 0. So we do not have to do the whole fraction less than 0. My denominator must be negative. So we can just say, when is my denominator negative? It's way less work than trying to deal with x's in the denominator. It gets a hot mess. So my denominator must be negative. So all we have to do is solve this guy. 3x minus 5 is less than 0. Add 5. So we get 3x is less than 5. So x is less than what? 5/3. So our negative infinity to 5/3 in parentheses. So when the x is in the denominator, look and see if there's a shortcut we can take, because usually there is. If my whole fraction has to be less than 0, my whole fraction is negative. If that numerator is already positive, I know that denominator is negative. I know it. So then let's look at this one. If a fraction is greater than 0, it means this guy's got to be positive, right? It's got to be positive. So x minus 7 has to be greater than or equal to 0, right? So what is x equal, or what is x greater than or equal to? 7. Hang on a second. If I put 7 in here for x, what do we get as our denominator? 0. Can I divide by 0?
No.
So can it equal 7? No. So this is the only time our inequality sign is going to change. Is it cannot equal 7 exactly.
So would it be greater than?
So it's just going to be greater than 7. We can't equal 7 or my denominator is 0. It cannot be 7. So this can go from 7 to infinity, but it can't be 7. It could be 7.001. It could be 7.0000001. But it cannot be 7. Because then I'm dividing by 0 and the world falls apart. Because fractions do not like zeros in the denominator, right? We will practice more with these and with inequalities and stuff tomorrow. But there's homework 2-6. Okay, homework 2-6 is due Tuesday because we don't have school on Monday.